This lesson I'm going to be teaching oxidation numbers, so you should have your notes in front of you ready to take notes, please. So oxidation numbers are something we use to figure out redox equations when they're not straightforward. When we are dealing with something that's not ionic, we need redox to be able to figure out if this compound has gained or lost electrons, okay? So many chemical reactions involve the loss or gain of electrons by atoms, ions, and molecules. The loss or gain of electrons can result in a change in the charge of a species. For example, when sodium atoms lose electrons to chlorine, each species acquires a different net charge. Sodium becomes +1 and chlorine becomes -1. Knowing how to draw Lewis dot diagrams for atoms, ions, and compounds can be an asset, but at the same time, I'm not going to worry about that too much. So the Lewis dot diagram, so LDD, shows you valence electrons of elements and how they join. Once again, I don't worry about these too much. Lewis dot diagrams. If you know the rules, it's a little bit easier than doing Lewis dot diagrams. So the oxidation number is the actual or hypothetical charge of an atom or ion. So this is a way of keeping track of electrons in a particular species. So in a redox reaction, two elements undergo a change in oxidation number. The oxidation number of one element will increase as a result of a loss of electrons, while the oxidation number of another will result in a decrease as a result of a gain of electrons. So your oxidation number decreases. That means it's reduction, and you are dealing with the oxidizing agent, the OA. If your oxidation number increases, you're dealing with oxidation and the reducing agents, remembering that our agents are double agents and they mean the opposite. So let's go through this example here. So we have sodium plus chlorine to produce sodium plus and chlorine minus. So each sodium atom is electrically neutral. When a sodium atom loses its valence electron, the net charge of sodium changes from 0 to 1 plus. So you have sodium turning into Na plus and with 1 electron. Since it's electrically neutral, so the number of protons are number of electrons, a sodium atom is assigned an oxidation number of 0. Okay. Since the sodium atom has 1 less electron, it is assigned the oxidation number of 1 plus. So note the location of the plus sign. The sign always comes first in an oxidation number. So in math, you would sorry, not in math, sorry. I lost track of spot for a second. This is an oxidation number, so you write it the same as in math. While traditionally, if you're talking about a charge, we say 1 plus, or like sodium plus, but oxidation numbers, we say plus 1. I'm not going to worry about that too much, just letting you know. So since each chlorine ion has 1 extra electron, each is assigned an oxidation number of -1. So on this side here, he is an element, so his ox number is 0. Well, over here, both chlorine atoms have a 1 minus charge, so his ox number, so his oxidation number is -1. Cool. So pause if you need to. I'm going to move on. So since two atoms in chlorine have the same number of electrons as a neutral chlorine atom, each chlorine atom is assigned an oxidation number of 0. I should really read the next page before I write notes. So you have chlorine here being a 0. These are your oxidation numbers. Chlorine minus is 1 minus. So there are at least two ways to assign oxidation numbers to the elements involved in a chemical reaction. So one method involves drawing Lewis diagrams for the species and using electronegativity values to assign oxidation numbers. A second method requires the use of a set of rules. I'm going to get into this second method. You can do Lewis dot diagrams. I'm not going to. I'm going to worry about the rules. So oxidation numbers with assignment numbers. There is a well-established set of rules for assigning oxidation numbers to elements in a chemical reaction. Mastery of these rules is essential to success. Each rule is presented below. One or more examples of its application are provided. So the first rule, it's an element is equal to 0. So the oxidation number of a pure element is 0. So remember in thermochemistry when I talked about pure elements, standard millimolar enthalpy of formation is 0. Same thing here. When you are dealing with an element, its oxidation number is 0. So atoms of pure gold are electrically neutral. The gold atom is assigned the oxidation number of 0. Fluorine atoms in F2 equally share their bonding electron pair. Each atom is assigned the oxidation number of 0. Okay, so knowing all this, guys, we need to know our 7-up and our P, is that how you make a P? I don't even know right now, and S8. These are your elements on top of the rest that are just found on the periodic table by themselves. Our 7-up, which like is H2 and O2, N2, F2, Br2, Cl2, I2, all are elements. They're 0. P4 is 0 and S8 are 0. Remember how I called them the weirdos earlier. Okay, that's rule number 1. Rule number 2, if you have a simple ion, the charge is equal to the oxidation number. So let's highlight this. For a simple ion, the charge is equal to the oxidation number. So assigning oxidation numbers to the most monoatomic ions is simply a matter of identifying or determining the ion charge. For example, ions of group 1 metals are assigned to the oxidation number of 1+. So that's like Na+. His oxidation number is plus. Li+, his oxidation number is plus. Ions of group 2 metals are assigned to the oxidation number 2+. So that could be beryllium, 2+, magnesium, 2+. So if you're asked, what is the oxidation number of sodium plus, you would say 1+. It's a simple ion and it has a charge of plus. If you're asked for magnesium, what is its oxidation number? You'd look at the charge on the periodic table and tell me 2+. Okay, so these are when they're ions. Okay, ions have a charge. The first rule is elements, and as a reminder, there are no charges for elements. If something has a charge, it is an ion. The last example here, ions of group 17 or group 7A, nonmetals, are assigned the oxidation number of -1. So that's your fluorine, your chlorine, etc. So because these are simple ions, its oxidation number is, so ox number equals -1. Okay? Pause if you need to write down some notes. From there, rule 3, hydrogen. Hydrogen is 1+. Okay, hydrogen equals 1+. But always above, okay? Metal hydrides, where it's a -1. Okay, so metal hydride would be like when you have sodium, hydrogen. I never see this compound because it's not commonly occurring. But in this compound, Na plus is the positive and H is acting as a minus. What, miss, are you talking about? H acting as a minus? What? In reality, friends, on our periodic table, we have 1 plus, 1 minus, and hydrogen can act as a nonmetal. It just usually acts as a metal with the positive. But when like sodium is bonded with this, it means that a metal is bonded with this. This guy is acting as the nonmetal. So he is acting with the negative there, okay? So something to memorize. I hate memorizing, but here we are. In a water molecule, hydrogen is bonded to oxygen by a polar covalent bond. The electron pair is closer to oxygen, making hydrogen partially positive and oxygen partially negative. Each hydrogen is assigned the oxidation number of -1. I think this is a typo. It's not in water. This is in hydrogen peroxide. No, I'm wrong. But I've never seen this rule before, guys. Like I said before, I used to use different notes, but I started using Mr. Norman's notes to make it easier for you guys. Ignore that. I've never seen that before. But this is a metal hydride here, okay? So calcium hydride here is hydrogen is in the form of a hydride ion. So that's when he's a negative. Hydrogen with a metal, he's going to be negative. This is when you assign an oxidation number of a -1. Usually, though, hydrogen is +1. The only exception I'm going to make you worry about is metal hydrides. Hydrogen is going to be equal to -1. Okay? Pause if you need to. From there, friends, let's talk about oxygen. So the rules we've learned so far, as a reminder, is elements are 0. Ions, simple ions, are equal to the charge. Rewriting things can actually help you learn sometimes. 3, hydrogen is equal to a +1 unless you have a metal hydride. It's a -1. So now we're getting into oxygen as a rule. So oxygen is assigned the oxidation number of -2 except in peroxides, like hydrogen peroxide where it is assigned in -1, and in OF2. So there are 2 exceptions to this. Oxygen is a -2. But, so big capital letter, except H2O2, O's ox number is going to be equal to a -1, and OF2, its ox number, so oxygen's ox number, so oxidation number, is going to be equal to OF2, it is a +2. Okay? So oxygen is assigned the oxidation number of -2, except in peroxides like hydrogen peroxide, where it's assigned a -1, and in OF2, where it's assigned a +2 due to the higher electronegativity of a fluorine atom. Consider these examples. So in calcium oxide, we have oxide ion has a charge of 2-, and its oxidation number is a -2. In water, H2O, the oxygen atom strongly attracts the valence electrons of hydrogen, and it's assigned the oxidation number of -2. From there, in hydrogen peroxide, H2O2, each oxygen equally shares 1 electron pair, but strongly attracts the bonding electron of a covalently bonded hydrogen atom. Each atom or each oxygen atom is assigned the oxidation number of -1. Never asked about this. This is trying to get you to understand it. If you want to just memorize that H2O2, oxygen's oxidation number is -1. And in OF2, oxygen's oxidation number is +2. And everything else, the rule is oxygen is -2. That's fine. I will never ask you to explain why. I just need you to know those exceptions. From there, covalent compounds. So covalent compounds, they are all nonmetals. As a reminder, $10, you had forgotten that. But ionic compounds are a metal and a nonmetal. Covalent compounds are nonmetals only. So when you're looking at a covalent compound, we have to look at electronegativity. So whatever compound or element has the higher electronegativity, we're going to take their charge. And other elements has to cancel to become neutral. So, in compounds that do not contain hydrogen or oxygen, the more electronegative element is assigned the oxidation number it would have as an ionic compound. So, if you are forgetting Unit 2 of Chemistry 2202, can't really blame you. You have a lot of things to learn every year. Electronegativity is right here. You can see it on your periodic table, friends. Electronegativity is right here, 2.1. Like, for example, fluorine's the most electronegative thing. It's 4. Oxygen's 3.5, and so on. So electronegativity is right there, given to you. So if we're looking at sulfur dichloride, chlorine has a higher electronegativity. So if I look at this, it's S with Cl. Chlorine is a 3, while sulfur is 2.5. So I'm going to give chlorine the charge he has as an ion, which is a -1. Chlorine is a minus. Sulfur as an ion is -2. But in this compound, he's going to act as a +2. How did I figure out that it's a +2? You can do a bit of math. So this makes sense to me, but it doesn't make sense for all students. So in SCl2, you're going to have S plus 2 chlorine to give 0. So in compounds that do not contain hydrogen and oxygen, the more electronegative atom or element is assigned the oxidation number it would have in an ionic compound. So when you add these up, chlorine is the one that wins. So he's a 1 minus. And they have to add up to 0. Okay? So to have a 2 minus here, right, to giving to 0, I must have a +2 here. So sulfur here is a +2. Do you need to write out all this math? No, but I'm trying to teach it to you, and hopefully when you realize, okay, chlorine's going to get the charge of -1, there's 2 of them. So it's -2. The sulfur needs to make it positive. -2 plus 2 equals 0. From there, there's another example here, iodine monobromide. Bromine has a higher electronegativity than iodine, so it is assigned -1. This one's an easier example. So if you have IBr, the electronegativity of iodine is 2.5, while the electronegativity of bromine is 2.8. So bromine is like, I always say it like the stronger element. Electronegativity is like how much can you pull other elements into you? Like how much attraction forces do you have towards electrons? So it's like they're playing tug of war, and the stronger the element, it means that you have the stronger electronegativity. So bromine here is going to be given a -1 charge because he has more electronegativity. That means to make this neutral, so iodine, plusing all these together, it has to be 0. This guy right here is going to be 1. So you have -1 plus 1 to give 0. Okay. So covalent compounds, you look at which one is your most electronegativity or negative. You take their charge. Then you have to look at the whole compound, and it has to be neutral. So you have to figure out the other one. And for sulfur here, there was 2-, he had to be 2+. For iodine bromide here, he was 1-, which meant you had to have a 1+ to give a 0. Rule 6 was actually kind of touched on in Rule 5. This is true for any compound, okay? The sum of the oxidation number in a compound is 0. So I just showed you that up here, but this is true for any compound. Trying not to. I'm writing so much. True for any compound. So if you have an ionic compound, the sum of both oxidation numbers is 0. So sodium plus here is a simple ion. He's a plus. Chlorine is a minus. 1+ minus 1 equals 0. That is 0. So the overall charge, overall numbers for oxidation numbers of any compound is going to be equal to 0. So when you add two elements, oxidation numbers together to get a compound, it has to be equal to 0. So water, on the other hand, oxygen has a 3.5 electronegativity, while hydrogen only has 2.1. So oxygen becomes O2-, so it has an oxidation number of 2-. Hydrogen is going to make up the rest. So -2 for oxygen plus 2 hydrogen equals 0. The 2 hydrogen here has to be a positive 1 to get 0. So -2 plus 2 to give 0. Hopefully that makes sense. Polyatomic ions are very similar to the last two concepts, with it being equal to 0. The only difference is polyatomic ions are when we have to make it equal to the overall charge. So the sum of the oxidation numbers of the elements in a polyatomic ion must be equal to the ion charge. So carbonate ion is CO3 2-. Oxygen is going to be assigned the oxidation number of -2, because that's the rule for oxygen. This is not a hydrogen peroxide, and this is not a metal oxide. From there are 3 oxygen atoms in the formula, so the total negative charge is 6-. Okay, so we have carbon plus 3 oxygen, so I'm going to write down OX because that just looks like 30, equals the charge of -2. You know that carbon, or the oxygen, is going to be -2. So this is going to be, when you rearrange this, you have a -6 right here. Bringing it over, you have a +6, right? It's a negative on the left. When you bring it over, it becomes positive. -2 plus 6. Carbon in this compound is going to be a +4. Let's go through the other examples. Sulfate, SO3, oxygen is assigned the oxidation number of -2. That's a rule. There are 3 oxygen atoms in the formula, so the total negative charge is 6-. So let's look at it again. S plus 3 oxygen to give a -2. So that's 1 sulfur and 3 oxygen. Sulfur we're unsure of, but we know oxygen has to be a -2. So when we bring that guy over, it's going to be a positive 6. So we're going to have sulfur being a plus 4, same as carbon up here, because the math is the same. Sulfate, on the other hand. So let's look at sulfite, SO3 2-, versus sulfate, SO4 2-. So you will see now that oxidation numbers of a lot of our elements change depending on who they're partnered with. So for sulfate, you have sulfur plus 4 oxygen to give 2 negative. So sulfur plus 4 times -2, the oxidation number of oxygen is -2, equals -2. So you're going to bring that guy over and you're going to plus 8. So you're going to end up with sulfur in this compound having the oxidation number of -6. Or not -6, sorry, +6. So you can read the information here. Hopefully my math is helping. Ammonium is the last one. And I think there's a couple more things, and I will quickly done the video. Sorry I'm talking so much. Ammonium ion, NH4+, the hydrogen is signed +1. So hydrogen is only ever a 1- when it's with a metal hydride. Ammonium is not one of those. There are 4 hydrogen atoms in the formula, so the total positive charge is 4+. And since the ammonium ion has a charge of 1+, the oxidation number of nitrogen must be -3. So I find that confusing. I have to do some math. So I have nitrogen plus 4 hydrogens, and its overall charge is the charge of the polyatomic, which in this case is positive. I know, because there's a rule specifically about hydrogen, that he's going to be 1+, and this is equal to 1+. When I bring that over, it's going to be -4. So in this case, nitrogen is a -3. The oxidation number in ammonium ion is a -3. So pause the video if you need more time to write your notes. From there, nitrate ion. So oxygen has a rule about them. So we're going to do nitrogen plus 3 oxygen. So I'm going to write down OX, so it's not just like 30 there. And this is equal to a -1. So I do nitrogen again, plus 3. The oxidation number of oxygen is a -2 unless it's a hydrogen peroxide or OF2. So you -2 equals -1. When you bring this friend over, you're going to put it as a +6. So that nitrogen here is a +5. The oxidation number of nitrogen in nitrate ion is a +5. So in summary, rules 5 to 7 are used to assign oxidation numbers to elements not covered by rules 1 to 4. By reviewing the examples above, you should see that an element can be assigned one of several oxidation numbers. So the sulfur that we just went through was assigned a -2, a +4, and a +6. So oxidation numbers change, okay? It depends on who they're partnered with. So a little joke here we see, hey baby, want to swap oxidation numbers? And it has to do with the fact that oxidation numbers change by which one you are bonding with. Let me do an example. So determine the oxidation number of the elements in potassium hydrogen sulfate. So I have KHSO4. So this is ionic. I'm going to split into my ions. So I have K plus and I have HSO4 minus. Miss, how did you know that HSO4 minus is a polyatomic? Because I've been doing this course too long, LOL. When you look on your back of your periodic table, you have the polyatomic table. And right here, HSO4 is hydrogen sulfate. This is a common polyatomic. So I just knew that. Hopefully with practice, you'll recognize your polyatomics. In reality, friends, unfortunately, I didn't teach you 1206 or 2202, but anytime you have a multi-element compound, this is polyatomic. So you got to look at your table, okay, friends? And there are no metals in the polyatomics. Maybe that will help you figure out what you're dealing with. So K plus, this is a simple ion. Let me just flick for a quick second. Simple ions are equal to the charge. That's rule 2. So the oxidation number of K is equal to 1 plus. I figured out one oxidation number that quickly. On the other hand, I got to split this guy up. This is not an easy one to start with. So there's a rule specifically about hydrogen, and it says that hydrogen is going to be a 1 plus, unless it's a hydrogen peroxide. No. Unless it is a metal hydride, it's 1 minus. So this guy is 1 plus. Cool. Sulfur, there's no rules about sulfur, so he is a big question mark. Finally, there's a rule about oxygen, and he is always -2, unless it's a hydrogen peroxide or OF2, neither of which is here. So when I set this up, I have hydrogen plus sulfur plus 4 oxygen, and like, once again, O looks like a 0. This is going to be equal to a 1 minus. So you have a plus sulfur plus 4 times -2, all equal to 1 minus. You bring that guy over, it's +8. You bring this guy over, it's -1. So sulfur here, friends, is a +6. So if you want to be really kind to Miss Kavanagh and rewrite your things, you can say oxidation numbers right here. K is 1 plus, hydrogen is 1 plus, sulfur is +6, and oxygen is -2. I just calculated all of my oxidation numbers using my rules. Okay, these are often multiple choice, but it's important that you know how to do them, okay? Sulfur in HS2O3 minus, H is going to be a 1 plus, sulfur is going to be a question mark, O is going to be a 1 minus, or -2, sorry. So we have H plus 2 sulfur plus 3 oxygen equals a -1. This is plus, this is 2S, this is 3 times -2 equals -1. Bring this guy over, that's a +6. Bring this guy over, it's a -1. So 2 sulfur here is going to be equal to a +4. I got to divide my 2 out. Sulfur is equal to a +2. See. Okay, I have been talking for 30 minutes. I hope this stuff is making sense, and you can work on the worksheet provided. Okay, I'll let the sub know what you have to complete. Thank you very much for listening. Have a great day.